All right, I guess I'll go ahead and start. This talk is called Metasploit Reloaded. The focus of the talk is the recent improvements to the Metasploit framework, which I'm a developer of. Kind of a quick intro to the agenda. First thing, introductions, who I am, what I do, that kind of stuff. Second, the reason for Metasploit 3, kind of what evolved to developing this version of the software and what it does and why you should care. Next, kind of get into the automation features available in Metasploit 3 that weren't previously available in Metasploit 2. Then get into a little bit of IPS evasion. Not going to touch too much on the stuff that I'm covering tomorrow with Brian Caswell, but enough that you can, to show you how to use Metasploit 3 to do different types of IPS evasion testing. And finally, some demos. Because this is a 75-minute talk, and you don't want to see my slides for 75 minutes, I'll probably finish up about 45 minutes into it with the slides, and then go straight into demonstrations and Q&A. So once we hit that point, ask any questions you want to, and it'll be kind of free form after that. So first off, my name is H.D. Moore. I work for a company called Breaking Point Systems based out of Austin, Texas, where I'm the Director of Security Research. We build hardware that breaks other hardware. So you plug a switch into our product, and we make your switch melt and burn up and blow up and all that kind of stuff. I'm also the founder and lead developer of the Metasploit project. We build software that breaks things and breaks them in fun ways and gives us shells afterwards. So that kind of sums it up. So what's this about? Metasploit 3, a whole lot of new features, a whole lot of different changes, basically redesigned the entire thing from scratch. Released beta 3.0 or 3.0 beta 1 today. So if you go to the Metasploit.com website, you can actually download that right now, and hopefully most of it will work. That's why it's still a beta. We went through 4 alphas, so to give you an idea of how stingy we are with calling anything a final release. A little bit of automation, kind of turning Metasploit into Nessus, like the different things you can do to the new version of Metasploit that allows you to use it for things like reconnaissance, discovery, automation, integration with other products, that type of thing. And finally, some of the IDS evasion stuff, kind of what's different from 2.x. This is probably more important to IDS vendors in the audience because they're going to have to go scramble because the code is now public. And finally, a trick I call offensive IPS filtering, where basically you develop an IPS for the attacker, so the attacker doesn't send anything it knows will trigger an IDS. So, nifty plugin. And after that, just demos. So Metasploit 2. Who in the room has used Metasploit 2, some form of it? Rock on, sweet. All right. It was released, the first version was released in like 2003, and it's this crappy little Perl script with a cursive interface, and SpoonM emailed me saying, hey, your code sucks. I'm like, okay, rewrite it if you care that much about it. He's like, okay. So that was it. That's what really started off Metasploit development, is him mocking my code and me telling him to freaking rewrite it if he hates it so much. So that kind of concept and working relationship is extended till now, basically. Right now, there's 4 developers on the project, or 4 main developers, and a whole lot of contributors. Out of those 4 developers, 2 are kind of part-time right now and just haven't put too much time into the project recently. Right now, it's Matt Miller and myself that really run it. There's 148 remote exploits in the latest version, which is much smaller than a lot of the commercial frameworks, but we count exploits as exploits, not as port scanners. So there's a difference in counting there. Some folks may be familiar with certain products that have 200 to 300 different exploits, where all those exploits do things like tell you what version some software is running. We don't believe that's really fair. Most of these other frameworks also only have one payload, which is their agent or their tool that they use to automate exploitation after the exploit is completed. We have 75 different payloads. You kind of mix and match as you want to. I did a Google search last night, and we're actually listing 22 books, over 2,500 blogs, and 300 articles. So, woohoo! We're at least media whores. So, if nothing else. Over 50,000 unique addresses have used the Metasploit update stuff since the beginning of 2006, and they're braver than I am. I don't even use it because it updates, remote code off of our server, which is a nice juicy target for anyone who wants to hit something. So it's amazing how many people out there are actually automatically updating and running code from military installations to the Metasploit.com server. So, I hope we don't get compromised, and we're definitely not going to start backdooring people, but at the same time, that's kind of ballsy, in my opinion. We have a lot of media coverage recently. We got covered in the 451 Group market research report, which goes out to like VCs. So it's funny watching a company that normally produces reports targeted for VCs covering an open source project. Like, well, we're kind of incorporated because we need something to hold copyright, but that's really it. So their opinion was, we don't have any competition, but everyone else who develops in the security exploit space is competitive to us. But everyone who uses those products also uses our product because it's free. So interesting, kind of dichotomy, commercial versus open source. Basically, it doesn't matter what commercial products you use, you're also using open source products, is what he said. So enough kind of, wanking on this stuff. Metasploit is dead. 2.x is old, it sucks, it's Perl, and Perl's great, and I love Perl and all, but it doesn't scale to 50,000 lines, especially when you have other developers trying to submit things, and you have to figure out what the hell they wrote. I actually did a test to see, is Perl line noise? A lot of people say, hey, Perl is line noise. Well, if you actually pull some bytes out of dev random and try to evaluate it in Perl, after you get past 8 bytes or so, only 2% of all line noise is valid Perl. So anyone who ever says Perl is line noise, you're only wrong 98% of the time. Anyways, kind of minor note on that. Load time really sucks. We have 200 modules right now, and the way the current Metasploit framework is implemented is it loads every one of those modules into memory. So if you're using, say, Windows to run it, and for some reason most of our users are, you end up using something like 40 megs of memory just to cache all these freaking Perl modules. It's a waste of space, it's really slow, and it isn't really designed to do things like client-side exploits. Recently, there's been a big focus on browser exploits, like WMF stuff, things like that. And for every one of those exploits in Metasploit 2, we had to write a custom web server to serve those exploits up. It's not really what it's meant for, and we see problems with it, and we're trying to figure out ways around it. But our fix for it was to drop the entire product and write something else. But on Windows, you're also limited by fork for concurrency. And if anyone ever tried to run a fork-based daemon on Cygwin, there is no such thing as copy on write. I don't know who's familiar with that term, but basically, normally copy and write means on a Unix system, when you fork your process, it only copies the pages of memory that have been modified. On Windows, it has to copy every single page. So if you're using the Metasploit web interface on Windows through Cygwin, and you accept, and first you've got a listening connection like a daemon, that's 1, and then you accept a connection, that's 2. You run an exploit module, that's 2 or 3, and you have a background session, that's 4. You're using 4 times about 32 megs of RAM just to have 1 exploit session. It's ridiculous right now. So if you have less than 200 megs of RAM, you really can't run Metasploit on Windows. And we're trying to solve that by moving to eventually a native Ruby interpreter and get around this fork thing. So yeah, Perl's a problem. Cross-platform support is horrible. Has anyone ever tried to port a Unix Perl program to the active Perl stuff and realized that the fork call now returns a negative value that's a valid process, but is really an internal thread? Anyhow, it's all kinds of problems with Perl on Windows. And Perl 6 should be released right as hell freezes over, I think, right? So we wrote the whole thing again. Long live Metasploit 3. We started off with the Metasploit 2.4 code base and actually split it off at that point. What you'll see now is Metasploit 3 is still kind of everything's being ported back to it from Metasploit 2, so it's taking us a while to synchronize the trees. It's an object-oriented model. We kept having to do weird things in Perl where we manually manipulate the symbol table in order to tell one object what its parent is at runtime or its grandparent is at runtime. And if you do O development, it's pretty back-asswards in terms of how you'd write something. We couldn't find a better way to do it in Perl. Also, Ruby's a lot nicer in terms of the number of lines you have to write tends to be a lot smaller, even though they run 4 times as slow. At least they look smaller. So we had about 40% code compression converting it to Ruby, but then we ended up writing twice as much code. So whether it's better or worse, we're not sure yet. But we're actually about 90,000 lines of Ruby right now as opposed to 40,000 lines of Perl. Completely new design. We actually decided to document something for once. So Scape, being the documentation creation engine that he is, created something like a 65-page document on how to use Interpreter, a 90-page document on how to use Metasploit in general for development. The guy's just a machine. That's the other lead developer on the project. So if you ever want to know how anything in Metasploit 3 works, there actually probably is a line of documentation somewhere for it. One of the issues with Metasploit is we created this thing to be modular, so you can take any piece and drop it into any other piece and put them together kind of like exploit Legos. We thought that was a really cool way to do exploit framework development. We don't really you don't have to depend on anything being there for most of it to work. And that works great until you want to do things like actually integrate features. You want to say, well, I want to find everything vulnerable to this and then target with this exploit. Or I want to make this payload automate with this other payload. These 2 exploits work together. And while you could do that, it was really clunky. We decided that there must be better ways to do that, and we created kind of an API for that in Metasploit 3. So this is the ugly architecture document if you actually care. Lots of little boxes with letters in them. Not very exciting. Basically, you can actually hook into the framework code at 3 different levels. You can do it at the Rex layer, which is kind of the generic Ruby library for doing anything exploit related. The framework core, which gives you the ability to basically create your own Metasploit framework using those APIs. And the framework base, which is actually the basic implementation of the entire thing. So from there, you can create your own simple clients interface, things like that. We have tons of interfaces, planning adding lots more, lots of different module types. You can add new module types really easily. The whole thing's basically been abstracted to hell, so it gets kind of complicated to figure out where anything is. At the same time, we can keep adding new features indefinitely. One of the issues in Perl, as mentioned previously, was to do more than one thing at a time, you'd have to have really crazy select skills. or you have to do a fork or try to create native threads, or do something that's basically OS specific to handle concurrency in your application. With Ruby, it has this concept of threads that are actually in process that are actually internally a giant select loop. So you don't have to create your own select loop, you let Ruby do it for you. But the nice thing about that is you can have 15 different things going on in Ruby at the same time in the same process, and it works the same way on every different operating system. You don't have to go retrofit this threading library in, or worry about nptl on this system, or pthreads on that system, or Windows being generally borked. It just works until you have a thread lock, and that's a different issue, but we've fixed most of those. Concurrent exploits and sessions. One of the things that kind of sucked about Metasploit 2 is if you're saying dropping the ISS exploit, the one that Woody Worm used, the really nice black ice, what was that, the ICQ response. If you start spamming that out to the broadcast port, which is a fun thing to do at conferences, so I hear, a lot of people run old ISS versions, and you start getting shells flooding back in. Well, with Metasploit 2, you can only handle one shell at a time, and you can't really mass someone with just one shell at a time. You really got to put more oomph into that to really take over a whole network at once. And there's a lot of really good exploits that if you can do a broadcast-style exploit or hit a whole lot of people at the same time, there's just interesting things you can do with that. A good example is like drive-by, malware installs and browser exploits. You put a JavaScript include that points back to the Metasploit framework. Anyone browses any of those pages, boom, you pop their browser, you get another shell. So being able to automatically interact with those shells and have multiple shells at the same time is one of the features that we wanted to put into Metasploit 3. So Ruby has this really cool feature called mix-ins, where instead of just the normal class inheritance with object-oriented programming, where you say this class inherits all the features of this other class, you can create modules that can then be imported to any class and share their features with that class. So you can say, I want a mix-in that creates that transforms an internal string representation into hex, and another one transforms it to Unicode, another transforms something else, and then extend the built-in string class to use that. So any string in any of your programming now has this new function, or new method called hexify or unicodify or something like that. So we use the same concept for creating different types of exploits. So if you're writing an exploit that does anything with the SMB protocol for interacting with Windows shares or Samba, all you have to do is include the SMB mixin, and that redefines all sorts of internal methods so that when you do like the connect call inside the exploit, it no longer just does a TSpeak connection, and now sets up the entire SMB login, everything else, exports new variables for you. So if you want to use one of these complex protocols or one of the things that we've already built in here, like FTP exploits, FTP API for it, all you do is include the mixin, and all those features are there for you. And it's all nice and extended at runtime, and the boilerplate code is really small for it, and it works pretty well. An example is here's an FTP exploit. That's the entire thing. Besides the meta information at the top, that's everything that you need to run code. That's it. You don't have to worry about the shellcode, the encoding, how to create FTP commands. And this also has the benefit of being able to use, does this do a login? No, it's the user one. Being able to use IPS evasion techniques, such as changing out your white space from regular spaces to tab characters, to like OXOC, to vertical tabs, things like that. As long as you use our APIs for it, your exploit model is now automatically capable of doing all these nifty IPS evasions. So we have lots of new interfaces. We're trying to find different ways to make the framework less painful to use. The first version had kind of like an iOS shell with tab completion, and some people like that. Some people just couldn't really get into it and just decided to use the web interface for everything. And we absolutely hate the web interface. We'll eventually make it cool, and we're still in the process of doing that, but it's not really the best way to use it right now. We're looking actually to like Ajax and kind of client-side scripting stuff, and the web interface to have things like Ajax shells for command completion and all that. So we're working on that. The modules are no longer this giant flat list of payloads, exploits, knobs, and encoders. You now have this entire tree hierarchy. So you can say, show me all the exploits in this tree that are related to Windows. Now Windows/browsers. Now Windows/SMB. Now Windows/insert protocol name here. They're organized in a way that we can keep extending it indefinitely, basically, without having to run into, how many files can you put in a directory and how deep do you want to traverse the tree to load your modules, things like that. So by changing it to kind of a tree structure, it really helps us with expanding the interface in the future. We've got a couple of people working different GUIs for it. The team in India that was working on the WX Ruby GUI sent the design doc, said they're working on it, and then didn't hear anything from them for 2 months. So who knows whether they're going to do it or not, but if they don't do it, someone else will. So right now, the current working UI is still the command line interface and the console interface, but we should have the real fun GUIs done pretty soon. And eventually, we want to make an API service. You can actually run the Metasploit daemon on one node, connect to it from another node, and basically proxy all your commands and exploits and sessions to that other system. So if you have a disparate network, you can actually spread these things around across your network and use all those nodes to mass pen test something. That's the goal, so we'll see how well it goes. Has anyone used the opcode database? or knows what it is or anything like that. So if you're working on like Windows and you're trying to find a return address for something, and let's say you're trying to find out how to exploit a box in Russia or a box in France, and they've got different language packs, you're not really sure, which return address works on that language pack. Normally, the only way to do that is either trial and error, or find something that doesn't change per language basis, or just kind of guess at it, or you have to go get an actual instance of that installed, look at the DLLs in memory, and figure out what return addresses are available for that language pack. What Opcode database is this giant Postgres database instance of every DLL across every version of Windows, across lots of different language packs, that we automatically scan to every one of those DLLs looking for different ways to return that take you different registers. If you're trying to find some way to get it back to the ESP register, we'll look for every type of instruction that when you land on it, will eventually take you to ESP. And right now it's kind of dumb. It only goes like maybe 2 instructions deep. It doesn't do anything crazy like EI's EAP interface or anything like that. But it's online, you can search it. So if you're trying to find a return address for a strange platform or a version you don't actually have with you, you should be able to do a search, and 80% of the time that return address will work, depending on if the application does anything strange with reinitializing that block or something like that. This has actually been integrated to Metasploit 3, so you can do command line opcode searching now. So you can say, I need a return address for this platform and this OS, and it gives you a big list of possible return addresses. Eventually, we want to classify every one of the Metasploit payloads, or excuse me, Metasploit exploits, so that when you run the exploit, it doesn't have a list of return addresses. It has a set of heuristics used to figure out what return addresses should work for your current target. So it'll take into account things like fingerprinting. So if I identify that this system's running Windows 2000, probably Service Pack 4, with probably English as the default language on it, then it just goes out and does a download from our database of every return address that should work for that system, and then caches them locally, and it picks different return addresses. And the nice thing about that is anybody who's doing IPS signatures in a really lame way, where they're looking for static return addresses, isn't going to be able to do that. We're going to change them out enough that it should make them have to work for their paychecks at least. So, a couple of command line tools. We have this thing called MSFP scan. So if you're ever trying to figure out how to pull information out of a Windows executable in a way that doesn't hurt, you can use PE scan for that. This lets you do things like search a given executable for return addresses, for certain patterns, for strings. Eventually, it's going to be able to dump resource sections. So if anyone's ever played with RT_HTML type resources and Windows DLLs and like cross-site or cross-zone scripting, and anyways, there's some fun things you can do with the local DLLs built into Windows if you can actually get a web request to redirect to a local resource on Windows. But anyways, you can use this tool for some of those things. Anything related to PE executables on Windows, you can use this tool for it. We're also working on a middle extraction thing. So basically being able to obtain the RPC instruction information and call information for any UUID contained within a given DLL or executable. And we're still working on that. We've got one version that works, but its output is in Spoon's kind of ghetto Ruby format that no one knows how to parse yet. So we have to convince him to actually make real IDL so we can parse that instead, and he's stubborn. So we'll see how it goes. So one of the biggest things that happened in Metasploit 3 is we had to rewrite freaking everything. I mean, different language, different everything else. And when we started rewriting these, we're like, well, we could just quickly port them over, but we're going to have a lot more bugs that way. So we went through and basically did full QA on it during the port process, having to create a copy of something, modify it, change it, look for better ways to exploit it. I don't know if anyone's ever seen the Metasploit exploit code for the SQL Slammer bug, like the UDP request starting off with OX04, long string, colon, port number. If you ever looked at the Metasploit module from 2x before like the latest 2.6 stuff, there's like 4 copies of the shellcode in the packet it sent. It was the most broken freaking exploit I've ever seen, and I wrote it. And I couldn't follow that damn thing. It's like, holy crap, that's the same thing with any development project. You come back 2 years later after you start writing something, you try to figure out what the hell you did, and you're like, this doesn't make any sense to me. What the hell was I smoking? You have to come back and kind of redo it from scratch. So that whole process of having to go through and rewrite all of our code again has found a lot of bugs and found a lot of different ways to improve our exploits and change things around. And it's also shown in a lot of cases where IPS vendors and IDS vendors have gotten lazy and just looked for how the old exploits worked. So, we're going to just look for this string, the way that this packet sent, and when in reality you can do it 15 different ways. The randomness levels really changed in the Metasploit 3 modules. Previously, we'd have things like big NOP slides here, or a long string that had the word like Metasploit, all hackerish someplace, kind of silly things like that. And we went through and rewrote every one of those places to use randomly generated strings. So if IDS was previously looking for those strings and they no longer exist, they, once again, they have to work for their paychecks. So we simplified the meta info fields. There's still way more than most people want to have. If you're running an exploit, you just don't want to fill out, when it was found and all the different references for it, but you can't get around that. I mean, the alternative to having these fields built into the module is doing something like XML, and I think people actually hate XML more than they hate embedding Ruby. So we'll find out. One of the cool things about mixins is they can redefine the actual exploit function. Every module basically exports a single function that's an entry point for when exploits called on it. However, when you do certain mixins, they actually define that method for you, and they call your callbacks inside that code. So if you want to write an exploit that automatically hits every target, like doing a brute force down a list of targets, you don't have to do that yourself. You don't have to tell the user to do it. You don't have to do anything basically but use one of the mixins for brute forcing, define a function called try target, and that gets past your target information, does it all for you. I mean, that's like kind of standard stuff with exploit development. You just don't want to, duplicate code, and you want to make sure that when you're doing brute forces, there's a standard way to do it and so on. And that's all integrated as mixin modules. Other mixin models do things like provide a built-in web service. And the cool thing about the web services in Metasploit 3 is that they can actually share the same web service between multiple exploits. Each exploit registers a URI handler that says, okay, when I see a request for something.wmf, give it to this exploit. When I see something for .exe, give it to this one. I see something for this JPEG, give it to this one. So when you're done, you end up having a single service that can handle 15 different exploits, depending on what URL you redirect the user to. And that's where it comes into play things like drive-by adware installs and drive-by web browser attacks, where you do things like inject a little bit of JavaScript code into a banner that gets passed around from page to page. And that'll actually load something from the Metasploit framework and then fingerprint the server with JavaScript and redirect it to the right URL based on what they're vulnerable to. And that's kind of where this stuff is heading. Wow, I'm flying through this, so try to slow down a little bit. Am I going way too fast for everybody? Like, I know I gibber like a monkey and all that, but if I'm speaking too fast, throw something at me and I'll duck and I'll get the point. Okay. Couple enhancements to the payload stuff. There's a lot of different payloads. When you think of a payload as an exploit, most people consider that shellcode. Well, shellcode's all fine and dandy, but there's a lot of exploits out there that don't really use real shellcode. They use things like PHP scripts you have to evaluate, or little bits of like shell script that you can tell it to run a command, like meta-character injection, for instance, on CGI scripts. The way that we've solved that is we came up with special payload classes that handle each of those generic cases. So for things like command injection, like you've got a meta-character injection with some stupid trace route script. Metasploit actually has payloads now that act like regular shellcode payloads, but actually use commands to do it. A good example is like, run telnet pipe to the shell command pipe to telnet again, and that actually results in two connections coming back to the framework. The framework accepts both those connections, figures out what direction they're in, like which one's input, which one's output, and then gives you a single shell for them. So it's nifty because you can use all these really kind of complicated command shell techniques to get interactive shells just via command injection. But from the user's perspective, it just acts like a regular shell. They don't have to really think about it more than, select this exploit, go. It also abuses things like the bin bash support for dev TCP, which is a cool hack if anyone's ever seen that. You can do basically TCP connections or reverse shells just using bash on most operating systems. So if you've ever used Netcat before, you actually do not need Netcat if you have bash installed with those options. Most distributions support it by default. PHP payloads, who's seen one of those PHP shell things on a compromised system before? Where if you browse to it, you get this nice little UI management thing. You can install backdoors and monitor processes. Those things are getting complicated as hell. Like I saw one the other day that it self-decrypts itself and it's all obfuscated JavaScript when it loads on the screen, and then it has a built-in file manager, and it was awesome. I wish I had that. That was cool. And the file I was looking at actually had 682 URLs going to different servers that all had that PHP script already installed. I found somebody doing drive-by downloads on a text file on their server that had basically nearly 700 shells just sitting there, and they all use this guy's little PHP file management thing that had all these Russian comments in it. And anyways, it's cool stuff, but we think that the good guys should be able to access that too. So we're working on similar payloads for the Metasploit framework that are either multi-function payloads for PHP, or they emulate things like a reverse connect shell or things like that. Who's actually used Meterpreter? Okay, it's a little bit less known. It's kind of, if you've ever used Core Impact or Immunity's Canvas product, Canvas has something called mostdef, which is this kind of client-side C compiler that sends assembly chunks over to the server that then runs them and has a kind of a standard API for it. Basically, it allows you to inject shellcode into the remote process and do anything you want to with it. Core Impact has one, and they call theirs agents. So you install an agent, then the agent gives you an API for doing things like that. Metasploit doesn't really have a standard payload. There isn't really, when you run an exploit, you have to know which payload you want. If the box has a firewall on it and you pick a bind shell and you screw up, that's your fault. We don't really hold people's hands in that case with regards to picking the right payload and selecting the right options for an exploit. But we do have this payload called Meterpreter that's kind of the standard Windows payload that you can dynamically extend at runtime. And the cool thing about it is you can do things like, with Metasploit 3, it has all these built-in modules built into it. Metasploit 2, basically you load specific extensions to it that add different commands to the shell. You can do things like list processes on the system, upload, download files, migrate from process to process, things like that. I'll go into that a little bit more with the demo. One of the nice things about Metasploit is at any point, or excuse me, Metasploit 3, is at any point while you're running the shell, you can drop to a Ruby prompt and type in commands to do your own scripting directly into the interface. So if you're doing something where you have to exploit 15 servers real quick, you can actually just go bang IRB and start writing out your script to script out those exploit automations right there and go. Like, you don't have to load a script, you don't have to load a plugin, you have to do anything. You can actually interact with the system while it's running at any time from the shell. And Meterpreter is the same feature. You can actually access the entire client-side API of the Ruby client from Meterpreter on a live Meterpreter shell just by doing bang RB from the shell and going through it. These examples here on the screen for process migration, that first searches the entire process table looking for anything called calc.exe, and then it duplicates the current socket handle of the current Meterpreter session into that new process and migrates all of its code into that new process. So for instance, if you're exploiting like the WMF vulnerability, and you know how that works. There's this big screen that pops up for the picture file and fact viewer, and basically the user's stuck looking at this big ugly blue screen with a hung cursor. What you want to do is automatically migrate yourself to a new process in the system, and find one that they're not going to be able to close really easy, like explore.exe, or if you have privileged access, actually going to something like lsas.exe or service host, and actually running your entire payload inside that. So it's a cool way you can actually hop around the system. We're working on a system now, or the code for now, to do kind of like process whack-a-mole, where when you first attack the system with a Meterpreter, it goes and copies itself into two other processes, and they both monitor the one that you're running in. And if anyone kills your process, they do kind of a vote, and they elect a new one. And so the migration moves into the new elected process, and then they create a third process, copy themselves into them, suspend again. So you can keep trying to kill off processes on the system, trying to get rid of the interactive shell that the attacker has in your box. But unless you're really, really quick, you won't do it. So it'll still beat you every time because it's running its code in memory. You can just hop around and create new stuff. And we're still working on making it reliable. We haven't put it into the new release because we don't want someone to try it and the whole session to go plunk, which is what happens now. Another thing you can actually, in this case, the API example, after you go to the IRB shell, you can mirror the entire hard drive of the system you compromise with one line. So that's a kind of nifty feature. That basically does a recursive copy of everything in C drive to /temp. So if you're doing a pen test, you really want to make sure you didn't miss anything, just copy the whole drive and call it done. And hopefully they won't notice their drive going chunk, 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 chunk the whole time, which is always, Has anyone noticed that you can actually use your hard drive noise as an IDS? If someone's doing RMR off in your box, you can definitely hear it. So that's you kind of wake up and groggily pull the Ethernet cable out and hope your files are still there. Sorry. Maybe I sleep too close to my computers or something, or at least you used to. So we have this thing called auxiliary modules. We try to find a good word for a module that does something that isn't your standard form of exploit. With Metasploit 2, we had kind of these like a few exploits that weren't really exploits. They allow you to do things like bypass authentication on a service and then use that service to download an arbitrary file, or do something evil in the system or some kind of administrative thing, but they weren't really exploits in the sense that there was a payload you injected and ran code. And while we could jump through all these different hoops trying to find ways to automatically install a backdoor based on having that access, it just didn't make sense to do it for every case. A good example is the Veritas backup authentication bypass. At the time, any version of Veritas that you found on the network, you can connect to the agent, bypass authentication, and then back up anything you want on the whole hard drive. And often you back up things like the SAM file or the registry high, things like that. And it was a neat way to do it. But it wasn't really a real exploit in the way that we thought of exploits being, or our definition of exploit at least. So we created this thing called auxiliary modules. Auxiliary modules, basically a module that does something. We don't really care what. If you have some kind of security tool and it can benefit from using our API, that falls in the category of auxiliary module. So you're running like a web-based assessment tool or a sniffer or some kind of like passive thing that monitors the network looking for something, or a syslog daemon, anything really. You can make it into a module, and that module can define its own command set. So for instance, you have a third-party backend you use for pen test reporting, and you want to be able to say, okay, I'm working on this host, now I'm done with this host, and I found some information on this host. You can integrate that as a plugin that exposes 3 or 4 commands to you, and that integrates with your own backend system, integrates with your pen test process. So it's really useful for anything at all. Right now we're using things like integrating with third-party tools, writing wrappers around things like nmap. So if you type nmap, it records the results internally and allows you to use like the ports open on the box as your tab completion for the console. So things like that, kind of just basically speeding things up using the tools that are already on the system. We also use it for like reconnaissance, port scanning, discovery stuff. We're really not trying to become like the Nessus or the Core Impact or the be everything to everybody kind of thing. But we do want people to be able to integrate the tools they already use with the framework. You can also use them to do things like report report data internally in a certain format and then export it back out again. So one of the things that sucks about having this huge framework with all these different things running at the same time is if you're trying to integrate things together, there isn't really a standard way to do it unless you create an API. In Ruby, you can redefine anything at runtime, which is cool if you want to basically replace a class or modify something, but finding the right place to hook into that was difficult. So we added this concept of events. So whenever a shell happens, an event gets thrown saying a new session started. Anytime a shell closes, you get another one. Anytime someone runs an exploit, you get another one, and so on. And you can, if you create a plugin, that plugin can then hook a certain number of events. Whenever it sees a session, it can just do rm/bang, and that's it. So if you want to have a plugin that automatically RMs anything you exploit, it's like 5 lines of code. Or you can have another one that basically copies out the SAM file or does something you do every time you do a pen test, a certain set of operations. Additionally, you can actually extend the objects. That event gets passed arguments, those arguments are the object parameters for whatever happens. So in the case of a session, you get passed a handle to the session, and they can then extend that session to do something else. So anytime someone types a command on that session, instead of it getting sent directly to the server, it then gets logged to a local XML database that you can do reporting on later on for your pen test team. Or it gets broadcast up with something. I mean, there's a whole lot of things you can do, and we're not kind of trying to define what the limits of it are, but definitely giving the ability to create kind of custom tools and custom wrappers, interfaces through the event system. So I mentioned it before, you can redefine anything at runtime in Ruby. This is even basic objects. A lot of folks on the Python camp say, well, you can redefine anything in Python. Like, yeah, except for the base objects. You can't redefine integers. You can't redefine operators for strings. Maybe you can, but maybe custom strings only. I'm not sure. But the nice thing about being able to redefine anything in Ruby is that we're not limited by the language. If the language has some method that we don't like, we just change it. So once you load the Rex framework and the Metasploit stuff into memory, all sorts of built-in functions change. Like the sleep call no longer calls sleep, and now calls select to be thread safe. Lots of internal things like that. You basically have full control over how the language works, because even if you're not calling a function directly, some other function may call, or some other method may call the method that you want to overload. You can overload that underlying method and do something else. It's also cool for doing things like tracing and debugging and extensions at runtime, things like that. The plugins are really cool because they can redefine anything, and they can actually define event handlers for all those different events we talked about earlier. You can actually make probably any type of exploit tool you like out of the framework, any other kind of security tool you like out of it, and it doesn't even have to be security related. You can have an administration tool based out of the same engine just by launching modules, waiting for an event, triggering it, doing something else. So it's kind of a generic event engine, even though it'd be silly to write like an admin tool that didn't use exploits. We added a database backend recently, which is still sort of under works. We want basically some kind of persistent storage interface to it. A lot of folks said, hey, why don't you just store all this stuff in memory, like your list of IP addresses? And that's great, but you don't want to store a /16 in memory. Like, if you want to reference any kind of information for that, it's just going to be, you're eat up a whole lot of memory for it, or it's going to be slow to parse, whatnot. So we took kind of the Ruby on Rails approach to it. Does anyone use Ruby on Rails for writing code? Okay, well, Ruby on Rails is fun. Not only is it trendy, but it's actually kind of cool the way it works. Basically, object wrappers on database instances, really easy to define handlers, that type of thing. So we stole active record from Ruby on Rails and applied it to Metasploit. We said, okay, now we're going to use active record to define host objects, port objects, session objects, vulnerabilities, notes, things like that. So there's different plugins you could load now in the beta version that if you have SQLite installed, which is the default database, the database driver for SQLite, it'll log anytime you do an exploit, or it will anytime you interact with the host, it'll then put that host into the cache and track information about it. And eventually we're going to have it so you can basically take your working list of hosts for a given pen test, store it in the local database, bring it up, and interact with that. And that still is hooked into the tab completion interface. So you can now tab complete all the hosts that you've already done a Nessus assessment on, for instance. So we have a plugin that loads like an MBE file from a Nessus scan, and then puts all those ports and hosts into your tab completion on the console. So it's not really done yet, but that's kind of where we're going with it. Plus, once you have the information stored in the database, you can do reporting on it with basically anything, just anything that can interface with that backend database. So kind of where this leads is if you want to do a vulnerability assessment engine out of Metasploit, this is how you go about doing it. Create a database backend, create a bunch of discovery modules that are auxiliary module types, a single event coordinator that based on the type of event routes it off to a different plugin or different module, and the report generated based on the database. And we started building this out probably back in February, and it's been going real slow because we think it's a cool feature, but it's not definitely not our core competency. It's not really what we're designing it for. So this will continue to improve, and hopefully within 6 months it'll actually be usable. But there's definitely something you can work with right now if you want to, if you look at the current beta. And if you want to turn this into a mass router, like Core Impact or something like that, or SS scan, if you remember the JS box old tool for it, and I don't know, I'm kind of dating myself on IRC here or something, but so you create discovery models that figure out what vulnerabilities apply to the target network or target host. You can actually call the check method of all the different exploit models to see whether that method either defines the check function, which is a vulnerability check function for any given exploit. A lot of those are actually defined, so you can say, not only can you type exploit command on the console, you can type the check command, and it tells you whether or not it's vulnerable first. So we're trying to find ways that you can integrate that with a vulnerability assessment kind of viewpoint and discovery viewpoint to automate your attacks. You can automate all of your post-exploitation stuff using plugins. So whenever a new session gets created, you register a session handler, and that session handler then goes out and installs your backdoor, adds it to your network of zombies or whatever you're doing, and goes from there. Finally, you can dump your XML reports via active record, and that kind of sums up, if we ever wanted to be like Core Impact, that's the direction we go with it. And there may be motions in that direction over the next 6 months, but it definitely won't be our prime focus. Because we have support for so many different protocols for doing exploits, let me backtrack. One of the biggest problems doing exploit development in general is that for every different weird protocol you have to support, you have to have your own library for it. Both Core Impact and Immunity Canvas are based on the Python programming language, which has this component called PySMB. PySMB is a client for NetBIOS and Samba and Windows SMB services. That's great, except for since everyone uses that library, in the case of Core Impact, they extended it and called that InPacket, I think is the name of their tool for it, or their library around that, is because they use kind of a public interface to it, they have to do a whole lot of work to make it support strange and interesting things. With Metasploit, we started from scratch and built our entire SMB library from scratch, our entire DCRPC library from scratch. So if you ever want to do just create like a basic Samba client in Ruby, there's actually a huge code base already in the Metasploit framework to do that, because we had to do all that work to support exploits. So you want to write something that can list files, download files, interact with them on a Windows share, the library's already there. So if you're writing something like that in Ruby and you need code for it, check out the Metasploit framework's libraries for it. That's basically it. I think the next section goes into evasion a little bit. Yep. So we kind of took evasion seriously. This is the first time we said, okay, we really want to screw those IDS guys because they've been too lax lately and it's really time to put the foot down. I mean, honestly, the IDS signatures I'm seeing on my day job are just pathetic. I don't know how some of them get past QA. I'm not even sure there is QA. I'll give you an example of a certain vendor that I can't name because I cracked the crypto on their signatures, so I'll give it away if I do that, and I like having access to their signatures. Backtrack again. So a company called Microsoft has a program where they provide zero-day information about vulnerabilities to certain vendors that create security products. The nice thing about that is they actually provide code samples, dumps of packet captures, things like that. I haven't actually seen any of these because I'm not part of that program and I refuse to ever join it. However, a lot of those vendors then turn around and create signatures based on that data and publicize those signatures. But the requirements on Microsoft's side is that if you release signatures about data that they told you about, you have to encrypt those signatures. However, they never said you have to encrypt them well. So there's some vendors out there that if you can obtain a copy of their signatures, you can decrypt them, and now you have vulnerability information for every single Microsoft advisory going back 5 years. And for somebody who does exploit development, this is awesome. I no longer have to like beg friends for information about a vulnerability. I just go decrypt the signature. Like, oh, okay, that's how it works. Cool, go call us. Or in the case, this is actually the case of a signature for a Qualys reported SMB stack vulnerability. And normally you look at signatures and it's kind of information about how to detect the attack, not so much how to launch the attack. So you have to think a little bit about, okay, what are they trying to detect and how do I write code to do that? In the case of the Qualys signature that I looked at, it was just a really long expletive string. .star regex, F, U, 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 C, 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 another letter, and then .star. And apparently that was their exploit signature for this attack they saw. So this particular vendor doesn't have a very good SMB parsing engine, and that's a good example why. But sorry, I'll get back on topic. And it's a funny side note on that stuff. So if you have a vendor and they have early access to vulnerabilities, a lot of vendors already do, and you find how they encrypt those signatures and you crack that, it's a really good source of information for exploits. So just putting that out there, if anyone does vendors like that. So IDS evasion is mostly a matter of figuring out, number one, how they decode the protocol, or two, how they match certain signature and making sure you don't hit those things. When we wrote the protocol stacks for Metasploit 3, we wrote them in a way that you can change almost anything at the lower levels at runtime with options provided by the user. So if you're doing an SMB attack that involves name pipes, or you're reading and writing to a name pipe, or using the transact name pipe API, the Metasploit interface can actually allow you to change the backend code for how it does those operations at runtime just by passing evasion options to it. So say you want to make your DCRPC fragments 1 byte long and have 10,000 of those. And you also want to make your TCP segments 1 byte long. And then you want to make your IP fragments 1 byte long. Well, those first two we have finished. The IP stuff and the raw IP stuff we're still working on. So it's a really nice way to say, okay, I want to test this attack, but with really crazy SMB options. And doing those types of attacks actually found more bugs in the SMB stack of the kernel and resulted in things like the mail slot vulnerability that was released last month. So which eventually we'll post. Actually, never mind, that code is actually part of the beta. So if you want to see a nice description of the mail slot vulnerability from MSO 6.035, download the latest beta and look in the auxiliary DOS directory, and you'll find an example there for remote heap corruption via SMB. Anyways, I'm sorry, I keep getting off track. So because there's all these evasion options integrated to all the different protocol layers, from the TCP stuff all the way to the SMB, to the HTTP, to all different protocols, you can actually do really nice evasion stuff. As long as the modules were written to use the protocol libraries, all these evasion options apply to it, apply to that exploit. So if you use our API for doing SMB or doing HTTP stuff, you automatically have all those IPS evasion capabilities built into your exploit already. You don't really have to do any more work for it. Good examples that a lot of people do a really bad job of detecting are like WMF when it uses HTTP plus compression plus chunk encoding plus JavaScript to self-decode itself. Surprisingly enough, ISS is a protocol detection engine actually detects that, where a lot of other IDSs don't. And it was just strange seeing a company that is usually known for having bad signatures do a good job of parsing something sometimes. But anyways, I'll shut up about that. They're actually making progress, so I won't kick them too much. Another example is the MSO 4.0.11 LSAS vulnerability, Stack Overflow on a named pipe. You do an SCH overwrite. You can use TCP evasion, SB evasion, and DCRPC evasion for that, and basically blow past most IDSs. There's a lot of things they do where they look for like the UID, or they cheat, or they try to find someone just talking that protocol or talking something like that, and you can use even lower levels of evasion like TCP and IP to bypass those. So something we're working on now is auxiliary models for fingerprinting an IDS, or excuse me, an IPS. So it'll send a packet that it triggers a low-res signature in that IPS, and depending on what responses get blocked and which ones don't, it'll tell you what IPS is in use and hopefully what signature pack they're using. Once you know the information about that IPS, you can then use the different options, an evasion profile to bypass that specific product. A nice thing about Linux-based IPS products, anything that uses Snort basically is an IPS. Almost all of those implementations are based on the Linux bridging interface. The way Linux bridging works is it basically takes all the packets coming on one side, reassembles them, puts them onto a BR0 interface that has an MTU65K for the entire IP packet, then reassembles them and pushes them back out the other way. So you can take advantage of the fact that it goes through a Linux bridge to detect anybody using an IPS based on the Linux platform. So you do different things with like reassembly stuff, and if you're attacking a Windows target, but when you do your attack, it reassembles it in a way that only a Linux bridge would, you know there's something between you and that target that's not your target. And those are kind of neat. I mean, it doesn't really do much for you. It's actually a cheap hack for preventing fragmentation-based evasion, because it doesn't really matter what the target OS reassembles it as. This bridge in the middle has to reassemble it like Linux does anyways. So it's not necessarily bad, but it does lead to an easy way to detect it. So the thermoptic camouflage talk I'm doing tomorrow with Brian Caswell's going to go into a lot more on this stuff, and I'm going to kind of tail out, and I cut a lot of the stuff I had for this out because I'm doing that presentation as well. So if you want to hear more about kicking IPS vendors in the teeth, that'll be tomorrow. So kind of a cool plugin for the a cool plugin for Metasploit framework that's based on IPS stuff and filtering is a plugin that filters your own outgoing traffic to make sure you never trigger a signature. So we took not all vendors encrypt their signatures, and if you can decrypt them, it doesn't really matter. But if you don't bother decrypting them, you can take things like the snort, rev expression, BCRE matches, and basically build your own filter for Metasploit that anytime you send traffic out, make sure it doesn't match. And if it does match, it throws an alert saying, no, sorry, change your traffic, you would have set up this filter. So if you're doing a pen test and you want to be really careful about what traffic you send, you can actually filter all socket operations in Metasploit to go through an application level filter before it goes out. So it's a different hack. You can also do that like the network layer or whatnot, but we thought this was a better way to do it. One of the challenges is a lot of these signatures are based on state information in the protocol. So you have to know that, okay, well, this flag is already set, or it's already at this level of the conversation, and my plugin's stupid and doesn't do that. But if you're targeting a stupid IPS, it works great. So we have a ton of other little research projects, so we're going to go straight into the demos. Escape's working on something called the Metasploit Research Toolkit, which isn't really supposed to compete against like, IDA Pro or anything Halvar is doing, but it's kind of a built-in disassembler, emulator, MMU. He wrote basically an MMU in Ruby. So it goes kind of slow, but you can basically give it a context, tell it where to start executing code at, and it follows the code to a certain depth and tells you what input gets pushed where and whatnot. There's examples of that on the Metasploit blog, which I believe is metasploit.blogspot.com. Nice function flow graph things like that. So eventually we'll use that for things like return address detection the way EI does it with their E tool or EEAP tool. I think I'm pronouncing it wrong. We have some anti-forensics tools. These have actually been integrated with Meterpreter modules. You can do that after you compromise the system with Meterpreter. And a whole bunch of random small projects on the website if you're curious about them. SpoonM's working on this thing called IDA-Rube, which is basically a network protocol to talk to IDA Pro with the Ruby wrappers on both sides. So you can automate all of your disassembly and function graphing and vulnerability detection stuff in Ruby. He's kind of a Ruby bigot, and a lot of people who work on the project are, so it's nice to be able to do everything in Ruby if you can. A whole lot of browser assessment fuzzing tools, like the Browser Fun project. We wrote a lot of tools for that, so a lot of these are coming in the Metasploit project as well. They're not directly related, but they're fun. Kind of a small note, with Metasploit 3.0, we did change the license on it. Before anyone shoots me over that, we went from basically a GPL/Perl artistic license, which is about as close as you can get to a BSD-based license, to a proprietary license that is still open source. You can still basically do whatever you want to with. But if you try to sell it to somebody else for money more than the cost of what you put it on, we'll shoot you. That's all there's to it. So there's actually a little line saying, tell us your address when, no, I'm kidding. It's not that bad. But we're basically trying to prevent people from doing commercial redistribution and rebranding of the code we wrote. And we didn't want to end up in a situation like Tenable Security did and like SourceFire did, where they're giving away a lot of information to people who compete against them. And although Metasploit isn't a commercial company, we don't really have competition in that sense. We want to make sure that people aren't free riding off our work without contributing something back, or at least saying they're using it. So if you do build a product based on Metasploit, great. You just have to give away your patches and basically give us royalty access to your patches if you distribute it. And you can't distribute a modified version on its own. You can distribute your patches and then the original version, tell people to put them together. But combining that and calling it Bob's Metasploit will get you in trouble. So hopefully people understand that. We don't want to cause too much of a stir there, but we want to make sure the project can continue and people who work on it don't feel like their work is being stolen. So that's the problem with open source. We know we'll never make money doing open source stuff, but we want to make sure that other people won't either. So that's basically it, at least not based on my work. Metasploit's actually working with a group called the Hacker Foundation, which is a 501c3. Actually have a meeting with them this week to kind of figure out how to make Metasploit more of a nonprofit organization that can do things like take grants and bring on interns, things like that. We really see Metasploit as an educational opportunity for a lot of folks who don't really know that much about security or exploit development, and a good way to let people kind of cut their teeth in the world of exploits. And we see kind of partnering with the Hacker Foundation is the first step towards that. And eventually we'll have t-shirts, but right now they're still vaporware because of the miscommunication with the printers. But anyways, demos, that's it so far. So if you want to hang off the demos, great. If you get sick of me talking, feel free to leave. You're not going to hurt my feelings. So on to the demos. Yeah, talk if you want to. Just take me 1 second to get rolling. And pick a nice juicy XP source peg 0 target with every bug known to man on it. So the first thing you do when you install Metasploit is usually start up the console. I mean, people probably use other interfaces, but the development group and just whatever we know uses the console interface. The console is cool because it has built-in tab completion. So if you're used to a Unix command line, it's great. You just do pick this exploit, do something, tab complete your return out your targets, your payloads, everything else. It's a little bit slow to run. As we said, Ruby's probably about 4 times as slow as Perl and kind of just raw numbers. I'm sure with integer performance a little bit differently, but that's just what we've seen. Let me go ahead and remove my config so it's not too much cheating. And of course, every time you start up, you get a fancy new logo. So if you care about fancy little ASCII art logos, and if you have a great ASCII art logo for it, set it in and we'll add it. So as long as it doesn't have genitalia or something like that, and we should be able to use it. We try to make it work safe still. So you start it up, tells you, how many exploits you have, how many payloads you have, how many encoders, NOPs, and auxiliary modules. That's all pretty basic. Most people just want to pick an exploit first. The first thing they do is just do show exploits. If you type show X and then do tab, it completes the show exploits for you. So we haven't ported everything over yet. As we said, with version 2.6, there's about 148 exploits. With 3.0 beta 1, we've only got about 90 in it. And there's probably 30 or 40 we still need to port, and then 20 that need to be converted to auxiliary modules or recon modules instead. In this case, we're going to be attacking a Windows XP system, so we'll grab one of the fun Windows exploits that always works. Everyone loves DCOM, so I'll pick DCOM first. So if you do use Windows, use module type, you can actually, one of the biggest differences between 3.0 and 2.6 is you don't have to use exploits. You can actually use payloads now too. So if you want to use a payload, all it does is give you a prompt that you can generate copies of the payload and see more information about it, generate NOP sleds. So even if you don't use Metasploit to develop exploits, you can still use our interface to generate the shellcode and the payloads and the NOPs and encoding for your tools, even if you hate our interface. So in this case, we're going to use exploit Windows tab complete. That's a big ass list of Windows exploits. Windows/DCRPC bugs, and here we see the MSO 5017 Microsoft Management Queue bug, as well as the DCOM bug. We're going to pick DCOM because it's fun, and first show targets. Oh look, there's only one target and it works on 15 platforms. Awesome. So thanks again to Dino for helping us out with that and getting all the buffers to line up right and stuff like that. So this man kind of pioneered the multi-target DCOM exploit, and now he's cringing, so my work here is done. All right. So set target 0, and see tab completes all of it out for you. Next we want to pick a payload. In this case, we've got a whole lot of payloads. Most of them are for Windows, so we get a big list here. And if you look at the way the payloads are described, payloads are listed, there's payloads, which is Windows / basically platform / what the payload does. Does it execute something? Does it inject a DLL? Does it create a VNC session? Does it load an interpreter? In this case, we're going to be boring and use a regular shell. So we're going to do set payload Windows / shell. And here's all the different types of shells we can have. We can have a bind shell, a find tag shell, which basically tries to reuse the socket, reverse HTTP that actually uses an ActiveX control of an IE to proxy exploit sessions over HTTP requests. It's still a little bit buggy in 3.0, but works great in 2.6. Reverse shells, and when you see in this case, you see Windows /shell /bind TCP, then you also see Windows /shell _ bind TCP. The difference is there's actually the way we define exploits is we created stagers and stages. So we've got basically a payload that it's all part of the same thing is called a single, or standalone. And when you run that payload, it does whatever it says it does. In this case, this would be a single payload here, which is Windows /shell bind TCP, just one thing. If it has a stager, in other words, it creates a connection that loads the next part of the stage off the network, then it has a slash in it. So you have Windows /shell, and then it loads the shell over a bind TCP or a find tag or reverse. So not really that important, but it's kind of if you see 1,000 payloads in there and you want to know why, it's because it actually automatically creates combinations of stagers and stages for you. So you can actually add a new stage that does something evil, like create a UDP, or create a new stager that loads over some other protocol, and you have access to all different stages, like a command shell and interpreter or whatnot. So set payloads, Windows shell, bind TCP. So this will create a listening port. When I connect to that port, I'll then send the second half of the stage over. It then loads that stage, and then hopefully we get a shell. We can set the rhost variable, which is the target. Let me show options real quick. Show options tells you what options you have to specify for that exploit to make it do something cool. In this case, give us a shell or do something evil. So we're going to do set rhost, which is the target. I think it's 128. If you do a save, it saves your entire environment, and you can come back to it anytime. It actually brings you back to whatever exploit you're working on last while your environment variable is set still. So exploit. Not very exciting. Still waiting for it. Command shell, yay, command shell. So, anyways, that's about as far as Metasploit goes. That's about as basic as it gets. However, with version 2.6, once you add a shell, you can basically type on your shell or exit your shell. There wasn't really much you can do with it. With version 3.0, you can actually Control-Z it, background it, and work on something else. And then use the sessions command to see how many shells you have. And if you have a web interface that automatically exploits systems or a broadcast exploit, you can add 50, 60 shells on that list right there and interact with them all you want, or automatically script something against all those active sessions. In this case, we're going to go ahead and just close the sucker out because it's not that interesting. We want to do session-i, 1. Here's our shell again. Yeah. Control-C, kill it, yes, okay. So, not very exciting. You can also just go straight to an IRB prompt at any time and then look at the framework object. So just check framework.methods.sort. Here's all the different methods you can call in a framework object already in memory. You can do things like list the current exploits. So framework.exploits, for instance. Framework.something. I think it's framework modules.exploits. That wasn't it. Anyways, you get the idea. We'll eventually publish an API for it. Right now, we keep changing it around, so it's hard to follow. But once you're done, playing around in the IRB interface, you can drop back out and go back to your shell. Now, instead of doing a basic, decom exploit, let's try doing one that uses like the new web service. So let's try to exploit, say, when you load IRB, it also kills your tab completion. So one of the bugs in the beta. So Windows, browser, see all the browser bugs. We've got the IE object type one. We've got the WMF one, the WinAmp one. We're going to pick the WMF bug to play with. So in this case, you see it has different options. Chunked, compression, header folding. These are all different kinds of IPS evasion options. So if the IDS is stopping your exploit from working, change some of these around. You can make it, compress the entire thing with gzip, break it into 1 byte chunks, things like that. Evasion options have little, they're the name of the type of evasion followed by : followed by the name. So if you do show options and you see those, that's what those are. All uppercase options are standard options, and then kind of camel case options are advanced options. So just kind of the mnemonics for it. There's no advanced options in this case. We're going to start with the web server on the VMware NAT interface, not my main IP. And we set the URI path, which is which path in the web server it creates that will handle WMF requests. We'll just call it /WMF. Make it simple. Show other options, run it. Sorry, have a big payload. And that's it, runs in the background. So you can keep going other things if you want to. The passive exploits kind of run in the background like this. And as new sessions come in, you see like a little note being displayed. Then you can use sessions-L and I to interact with it. We go back to our target box over here. We go Internet Explorer, please only. See, I actually tested it before I came here. This is in the history list. Hopefully it'll work this time. There you go, picture and facts viewer. So this is the screen I was talking about where if you want to migrate to different processes, it's a good idea. Because if I kill this, my shell will die. That's no fun. So the user is basically sitting in this little hourglass trying to figure out what the hell happened to him. And then you're sitting over here saying, hey, look, command shell opened. Session-L, look, got a new command shell. Okay, I want to interact with shell 1. There, I've got a shell on the desktop. Easy. So and if we do that again, no active sessions. Sucker's still running. Yeah, there's a shell. Let's get another shell too. Not sure if XP will actually open up to the picture file. Yeah, there it goes. Now we go back to our shell over here, and hey, look, we got 2 more shells. So basically, you can just keep loading them up. Basically, so if you're doing a pen test, you can set up your payload, set up everything else first, send out a link to everyone inside of a company with a link to your exploit server, and then just watch the shell show up and go with it. Or write a plugin that automatically, copies the home directory or notifies that they got compromised or touch something on the desktop. So for pen testing, this is really easy because it can handle lots of things at a time, and you don't really have to do anything funky to support it. So that's kind of the basic command shell, which isn't that exciting. Yeah, if you do like a JavaScript include that ends up redirecting the user to that site, you can use that to basically hit a lot of users at once. These are my notes, not too interesting. I showed you can suspend a shell, resume a shell, anything you want, any combination of that. I think the next up for the demo is the VNC demo. And for the VNC, let's use decom because it's a little more exciting. Use exploits, Windows, DCRPC, if I can type. I actually just can't type. That's why I built the tab completion stuff, because if I have to do more than 3 characters in a row, I usually screw it up. So think the host is already set right. Now, instead of using the bind TCP payload, we're going to use the Windows Windows interpreter. Sorry, still can't type. Windows interpreter. There's a list of different interpreters. These are different ways you can load the interpreter. Reverse TCP, reverse OR TCP, which is a smaller version of the first one, a stager, a non-stage one, etc. We're going to use bind again because it's easy. Maybe set a different port for the fun of it. Actually, no. Let's do VNC first. So the VNC inject payload, actually all the interpreter stuff is based on this thing called DLL inject that was designed by JT and Scape. And what it does, it loads the DLL into memory without writing anything to disk. So you have an antivirus installed that does on-access checking for the disk writes. It won't find any of this stuff. The only way to really see it is do memory forensics or memory scanning. In the case of VNC inject, it actually creates a VNC server in memory without installing anything else to the file system that just takes over the current desktop. It's kind of a neat trick to play with, and it works with a lot of things. It's always good for pen tests because you can actually see what the user is doing at the time you pop them. And if you're careful about it, you won't actually move their mouse or anything like that. You can actually just mess with them for a while before they notice. So same DCOM exploit. For large stages, we actually now have an intermediate stager. So in the case of the payload being, there's a thing called the Metasploit courtesy shell. So if you like having so the cool thing with Metasploit courtesy shell is that if you pop a system that has no one logged into it, what do, right? If you have VNC, has anyone broken a VNC desktop on a workstation that's been locked? How boring is that? You got nothing to do with it. It's like, okay, and I guess I can log in now. No, that's not what you want. You want a shell. So this gives you, you get this big Metasploit courtesy shell thing that pops up, and it's not really useful if you're trying to be stealthy, but there's now an advanced option to disable it. So if you don't want anyone to see your courtesy shell, you disable it here. Yeah, most people got sick of that, so we did something about it. Now let's say I log off and go back to the stupid XP logon screen. It looks like it was made out of, Playmobil toys. Wow, I hate the colors in XP. And we hit it again. We still got a shell. But wait, it gets more fun. I mean, we've got a shell. We can type some stuff. What happens if we just start up Explorer? So give it a second. Crap, I don't have a taskbar. I hope this works. Forgot it. It'll take a second to start up. There it goes. So who really cares if anyone's logged in or not? We don't. We still have a shell. We still have a full desktop, right? And it's always funny when someone comes back to their workstation and they see the please log in button, but with a start menu next to it, a bunch of crap open. Really kind of, it can ruin their day sometimes. So log back in as developer. I hope it works this time. We used to have it so VNC would actually follow a relog in. I think it's still a little busted. Yeah, back over here it crashed. So, VMware crashed. So, not our code. VMware just fell apart on us. We could draw things with our non-refreshing display. Yay! Okay, not that exciting. Crap! Did it again. Hate it when you accidentally exploit something. Okay. Okay, fine. Close. Next thing's demo is going to be the interpreter stuff, which is kind of fancy. If you're looking for a way, once you pop a box on a pen test, you always have to copy all your tools over to it and put them in a directory. Make sure you delete them when you're done. And it's just generally there's all this crap you have to do when you break into a box. It just makes it's really easy to leave things like. A good case study is I worked for a company once that they did a pen test and they left some tools that were password dumpers, things like that in the system. And we basically, in the report, we said, hey, we left these tools on there. We couldn't delete them because they're still in use for the operating system. We didn't want to reboot the box because it looked like it was doing something important. Please delete these tools because we can't do it from where we are in the pen test. The client said, okay, sure, we read the report, et cetera. And then something happened with their IT staff, and no one ever got around to deleting those. About 3 or 4 years later, we did an audit on the system, same system. They came back around and said, yeah, we want another test. And we're like, okay, well, all these tools are still here, so I don't know. It's just funny how little clients take care of their systems. Sorry, kind of a rant. Okay, desktop over here, everything's working again. This time we just do set payload Windows instead of doing VNC inject interpreter, and we'll do a bind again. You can make this reverse or whatever else you like to, or HTTP. Probably don't have to change the port, but I'm worried there's still a bug in the payload. So exploit it again. This time there's all these different random stages load up, so it takes forever to happen. So to kind of give you an idea of what happens, first we send the exploit. This has the original payload in it. This has the thing that creates a bind shell and lets us load the next stage of code. Then we send this 89-byte second stager that all that does is it waits for a length value from the client, and then it reads that number of bytes, then it runs that code. And then we send a 2800-byte stage. It's actually a Visual C program compiled and stripped back down to assembly that does the DLL injection. And then that loads a 73K other DLL that provides the rest of the information. And then that finally loads the standard API extension, which then provides the rest of the features. So there's all kinds of random network traffic happening on this, and I'm surprised it still works and it works reliably. But anyways, so once you get to the interpreter shell, you can type help, and you get all kinds of fun options. A whole bunch of core commands, which are like migrate, interact, and the IRB prompt for Ruby stuff. You can cat files, CD, download stuff, edit files in place on the system. Make directory upload, all the kind of stuff there for transferring tools. You can do some things with IP config, like look at interface information. You can actually do port forwards through the box. System commands, you can execute stuff. You can get your current user ID. So we just pop vcom, so our UID is system. Not very exciting. If you do get PID, it shows our process ID is 860. Now if you do PS, we've got to figure out which one of these is 860. Well, 860 is service host exe. And PS is built into the interpreter stuff, so you don't have to load anything else in the box like PS tools or anything like that. So we're currently in service host exe, but let's say we want to go someplace else. Let's say we want to jump into one of these other things. Oh, we still have some extra command shells sitting around. Oops. We can kill those off real quick. So now it's been a little bit since we looked at the system, so let's see what the last time the user used it. Well, 3 minutes and 9 seconds, the user hasn't done anything on their system. So we can actually monitor the idle time. So if we're trying to do something stealthy, like wait for the guy to take a bathroom break, if we restart owning his box, you can actually just keep monitoring the idle time. You see him go away. And let's say he comes back after he takes his leak, and you're still in the middle doing something like, hey, crap, idle time changed. I want to, I don't want him to screw with what I'm doing. You can disable his keyboard and his mouse. So we go over here and we have here's our desktop, move our mouse around, we can open stuff, it all works fine. Let's go back over here and say UICTL disable mouse. And he still has a mouse. Oh, that didn't work. That's no good. But the keyboard definitely does. I think maybe you have to do the keyboard first and the mouse, I'm not sure. It's a beta, damn it. Huh. I don't think it works when you've already launched the Explorer desktop on the login screen or something. There's some issue with that. Anyways, normally that works. It'll work when you try it. Let's see. So sysinfo tells you what kind of box do they pop? Like XP box, build 2600, no service pack, etc. Not really very interesting. The reg commands, you can do things like enumerate a registry key, dump the SAM hashes, anything you want to do from there. There's also another extension that's not built in. You can basically create your own extensions for this thing that provide any feature you want. And these extensions can be at any kind of DLL as long as you apply an API for it. So if you use our SDK, you can actually go build your DLL in Visual Basic if you felt like it, and use that as your shellcode. So if you've got mad elite Visual Basic scripting skills, and you put it into like a VB DLL, you can upload that sucker and then have all your pen test stuff automated via VB if you felt like it. Or you can do the same thing with Delphi or C++ or any other way you can write code that ends up being a DLL. Just as long as you follow our API guide, you're fine. In this case, I'm going to load the priv extension and, excuse me, where is it? Use priv, sorry. And now when you type help, we see there's a new section on the bottom called priv password database commands, which dumps hashes. Another one that's priv timestamp commands, which you can use to wipe all the forensic information off the file system. So there's a product called Ncase that looks at what we call the MACE, M-A-C, the modification, access, creation, and I forgot what E stands for, something else. What's that? Entry modified, okay. So, and this tool called Timestamp is what a friend of mine's tool does, which is the Anti-Forensics Toolkit. We'll go through and you can use Timestamp to basically trash all the MACE information off anything on the file system. So you're doing stuff, you want to make sure somebody using Ncase can't figure out what you did and when you did it. You just timestamp the whole damn file system. They can't track anything. There are no mod times anymore. Everything's zeroed out. So it's handy. The hash dump function, I would demo it right now, but because this freaking laptop has an NX support, and because VMware passes those flags down to the guest OS, there's a bug in hash dump where it doesn't set the page to be executable. So when we try to do hash dump to inject our code, it doesn't do any. It doesn't actually load it off the disk or anything like that. Hopefully no one's dying over there, but okay. So normally hash dump will, if you're 10 minutes, got it. So if you're doing hash dump on a normal system that doesn't have the NX chip installed, it'll basically give you the output of PW dump, and you can just crack it right away. You don't have to upload anything or do any kind of other magic to do it. Just bam, hash is done, kaboot. But if you do it on a box with NX right now, it crashes it, so we have to recompile our module, and it would be exciting if it worked, and it doesn't work, so I'm sad. But yeah. If you just want to get a regular command shell, you just do execute. So execute -f, the name of the command, in this case command exe. We want it to be interactive. Here's a command. Simple. If you want to launch some other executable, say the options. I think there's a show. You can execute a process image in memory, but it doesn't work too well yet. Let's say we want to create a calc exe process in the desktop. PS, okay, calc's over here. Go back to our desktop, and it's the same issue as the UICTL. Because we created that the desktop on the login desktop, all of our commands are being sent over there now. So I did the demo in the wrong order. I apologize. So that desktop still can't use its mouse for its keyboard, but this one can. So anyways, there's calc over there, I promise. I still want to switch to it because then my mouse will get locked up. But so calc exe, and say we're popping like your WMF, you want to migrate to this other process. So first you do get pid, figure out where you are, 860, we're still inside service host. Let's migrate ourselves into the calculator process. So migrate into 508. Takes a second, it has to duplicate the socket handle into it, copy all the code into it, reinitialize the crypto state if there is one. You can do built-in crypto with Meterpreter as well, but the staging isn't encrypted yet, so it doesn't really buy you much. Now if you do get pid, we're actually running from side pid 508, which is over here in calc. And it's nifty. I mean, if you're doing like WMF, for instance, you're running inside iExplorer, you need to pop to another process so when they close the windows and kill you, that's how you do it. We're still working on ways to automate that, so as soon as you pop the box, it creates a bunch of background processes and jumps into that and gets all stealthy and stuff. But yeah, still working on that. Of course, you can create files, list files, that type of thing. And it's nice because if you're used to like a Unix prompt and you hate the way Windows displays file access times, use Meterpreter and you get the Unix display. So here's our permissions and size and all that kind of stuff. So cd into the C drive. Okay, we've got some stuff here. Execute. So we're going to create a file called test.txt in the C root. Do ls, we see yes, it's there. Now if we want to edit that file, we just do edit. And it opens up whatever your current editor is and whatever operating system you happen to be running. So if you want to be able to edit all of your, like you want to deface a site, but you want to deface it using VI, you can. So yeah, this is my imitation of a really bad script kiddie. I can't even spell word right. All right, replacement. It's completely dead. It's still making noises. All right. So we only have about 5 minutes left, but I think that's a signal that we should, stop this and go drink a lot. So thank you for your time. If you have any questions, please come on up.